Okay, so we're going to start off with the 5-number summary. Now your calculator does this for you, and we'll go ahead and we'll look at the data. We'll look at some data later and ask our calculators to do it. But for right now, I'm going to go ahead and give you the 5 numbers based on some earthquakes, 207 of them actually. So the 5-number summary, as an example, would be it'll give you a maximum value, so the highest data value that you have. So let's say our max value is 9.1. It'll give you your third quartile, and let's say that is 7.6. Your median, and don't forget, another word for median is also what? The middle, or can we call it a quartile? Think about it, the second out of 4. So it's the half, the middle, the second quarter, halfway up. So you can also think of the median as the second quartile. Let's say our median is 7.2. And then we're going to go down to our first quartile. We'll make that 6.7. And our minimum value. So there's your 5. The minimum value will be 3.7. So you can go ahead and put that 5-number summary maybe in a little box in your notes. So what I want to do with you is I want to use this data to create a box plot. And because, and what we're going to look at from that box plot is how spread out the data is. Whoops. Okay? So you have to be able to do a box plot by hand to be able to identify what we're going to call the outliers. Values that really look like they don't belong. Okay? So that's why we're going to do it by hand. I know we're going to do it in our calculators as well to get a quick idea of what the data is shaped like. But as far as identifying outliers, a lot of times it helps to be able to do those by hand. Okay? So we're going to need to do that. So what you want to do for your box plot is we know our data is going to go from the smallest value of 3.7 to the biggest value of 9.1. So if I have this information, I can look at the smallest value and the biggest value and just make myself a little number line. So that's all I'm going to do. I'm just going to make a little number line. Okay? So my smallest value is 3.7. So what I'll do is I'll make this, I'll call this down here 3. And my biggest value is 9.1, so I'll call that up here 10. So that number line will cover all my data. Does that make sense? I don't want to go from 0 to 100. That would be dumb, right? You just want to look at your data and say, okay, my smallest... Whoa, I keep on hitting this in my book. I look at my smallest value, my biggest value, and I say, okay, make sure there's plenty of room for each. Okay? We don't get carried away with it. Okay. Now what you want to do is go ahead and find your median. Your median is 7.2. So your median is going to be your middle. So you can go to the middle of your graph and make that 7. And then what you can do is draw a vertical line for your median. You see how I made 7 the closest value to 7.2. I just put a little bit to the right. Now, your first quartile is 6.7. And your third quartile is 7.6. So I'm just going to break this up into even spaces. So I've got 4, 5, and 6. And here I've got 8, 9, and maybe I should have adjusted this just a little bit. So maybe I can make 10 a little shorter. Okay, so there's my median. First quartile 6.7. I'm going to put that there. And then my third quartile is 7.6. I'm going to put that there. And then I draw my little box there. So in your notes, you can put a little note where you got those lines from. This is Q3. That's Q1. And that is the median. Now, to be able to identify any outliers, before we go ahead and we put the whiskers on it, to be able to identify any outliers, what we're going to do is we're going to construct just a couple of fences, your book calls it. Imaginary lines. So what you're going to do is you're going to say, okay, I'll put this in the margin. So basically, your fences are just your quarters, so Q3 plus 1.5 IQRs, interquartile ranges, and then Q1 minus 1.5 IQRs. So let's stop and think about that for a second. I'm going to have my third quarter. I'm going to take my interquartile range. You guys remember what the interquartile range is? How do I get it? Yep, Q3 minus Q1. It's basically that distance right there from Q1 to Q3. So you're going to take 1.5 of those, go to the right, 1.5 of those, and go to the left. That's all. Okay? Now, so for my left side, my interquartile range is going to be Q3 minus Q1. Make sure you're not lazy about your notes when you put down how I'm getting this calculation, because you're going to have to do it. So that's going to be equal to Q3 is 7.6 minus 6.7, and that's going to be equal to 0.9. There's my interquartile range. So now, I'm just going to grab out my calculator. I'm working with some decimals. Doesn't make much sense to do much different. So I'm going to say Q3 plus 1.5 of those. So Q3 is 7.6 plus 1.5, 1.5 times 0.9. This could be 8.95. So I'm going to take this imaginary line here, 8.95. And I'm going to draw an imaginary line up there. And again, I just want to make sure we're grounded here. That imaginary line is going to help us to say, okay, anything beyond that line is an outlier. It's odd. It's strange. It looks like it doesn't really belong to our data. Because in statistics, sometimes we're allowed to take those outliers and throw them away. So we have to be able to say what they are first. Does that make sense? Like the kid that shows up to the test without his glasses on and decides to take it anyway, even though he can't see it. You can throw away his grade because it doesn't really measure what it was supposed to measure, right? So that's why we want to identify outliers. So let's go the other direction. Let's go Q1 minus 1.5. So Q1 we said was 6.7. And we're going to subtract 1.5 times 0.9. That's going to be 5.35. So I'll go ahead and I'll put my little fence up there. Okay, we doing good? Okay, so what you want to do is, to identify any outliers, is look, what do I know about this area right here? What does that tell me? How much of the data is there? 25%, we agree? So you're going to have 25%, so a quarter of your data is here and a quarter of your data is there. Pretty tight to that median, right? And then if we go from this median out another 1.5, doesn't it make sense that if we can fit all of our data in a box that wide, that we should be able to fit the rest of it equally in a box that wide, right? So all your data should be, or I don't want to say should be, but it would make sense that it would all be within here because that's about the same size. These are about the same size, but it's not, as a matter of fact. So when you want to identify any outliers, what this 1.5 gives you is it gives you a big enough distance away from the median to say, wow, that's more than this length. That's 1.5 of these. So if I have 1.5 of these going to that green line, and that data point still doesn't fit in there, that's got to be an outlier, right? And it's just so far away from the median. Does that make sense? It's just a guideline. Nothing exact, but it's the way to kind of identify stuff that really doesn't make sense. So we took a length of a quarter, we tacked it on, then we tacked on another half. And that's where we got our green line. So now if data is to the right of that, that's far away. Okay? So now we can go ahead and do our box and whiskers. We can say, okay, the smallest value is 3.7, so that's going to be here. And the biggest value is 9.1, which is going to be there. So I know there's a lot of writing on the board, but do we look like we have very many outliers on the right side of our median? Earthquakes? No, it looks pretty good there. There may be a couple, maybe one or so. But when we look here, we know that 3.7 is definitely an outlier. And any value in between 5.35 and here, that's going to be outliers. And anything in here is going to be an outlier. So if I wanted to shade it in just to kind of help you see it, it would look something like this. So basically any data that lies in there, we could call an outlier. And just there. So you could look at your list of data and say, okay, it's in this range here, it's an outlier. It's in this range here, it's an outlier. Okay? Give me some questions. Are you guys okay with that? Okay. So, I think we can stop this now because I don't have anything else to do. When you look at that box and whisker, you see that half of the data is to the left of our actual mid-range. If our range goes from 3.7 to 9.1, most of our data is here, to the right of the midway point. So our data is going to be a little skewed to the right. We're going to see more outliers to the left, so there are probably more data points down here for earthquakes of lower magnitude. You can see that the data is kind of tight to the mean. Most of the data is kind of tight to the mean, so there's going to be probably a unimodal data. It's all kind of tight there, so you're probably going to have one mode. That's all the kind of things you can tell from a box and whisker. All right.